I'll be discussing how to interact with a smart contract through Brownie. And for this, I have already set up my Brownie console so as to save time. And I've already written the codes that needs to be written in the terminal because the time was less. So we first we'll run the deploy contract command to deploy the smart contract, and as you can see here, the smart contract is deployed. And then we'll use the dir command, dir counter, to get the methods in the smart contract. And we can also put it as this, and then we'll use the counter. We'll use the counter read to read the value of the counter read. After that, we can we'll increment the value of the counter. Now this is done by txn equals counter dot increment, and now the value is incremented. As you can see, the now says 1 now, and we can just check it by counter dot read. It's 1. And after it's done, we'll create an account with these two commands, which are, first one is this, to get the accounts from the Ganesh server, and then to display them. Okay, and it's set up. Now we'll try sending some ethers, maybe 1,000, to Alice. So first we'll create those. We'll create the account. After it is done, I'll use the transfer ether command to transfer the ether. I'm sending 1,000, and then I'll specify all the values from to gas value, everything, nouns, everything. And after that is done, I'll use the sign transaction command to sign the transaction, and then we'll send it. Finally, we get the balance of the Alice. So Alice balance, that's it. And you can see the balance of the Alice now is 10. And then we'll save the account and load it. Since I've already saved my account with the password, I'll load my account. We will need to enter the password. After entering the password, it will load my account, and then we'll import some functions from Brownie for writing tests for the Brownie for the smart contract. We'll import some things, and then we'll create a Python fixture for deploying the contract that we have. That we need def counter, and we need return accounts for deploying, obviously. After that is done, we can simply write this command for Brownie tests, but we need to do this we'll need to do this by pressing Ctrl D, and then we can paste the command here, and it will get the desired result. As you can see, it's processing, might take some time. You can see it takes 30.24 seconds. So this is it for the Brownie, and now I'll discuss about the Web3, how to interact with smart contract in Web3. Now let's play around a bit with Web3 and smart contracts. As I mentioned before, to save time, I have written all the commands here in text editor before myself, and then I'll copy and paste from here. So first we import the Web3, then we try to interact with the Web3 server. And for this, we also need to have a new window, and in that way, I need to run We also needed the smart contract being deployed on another terminal portal, so I did that. And then we'll get the account that we created with the brownie. We'll try to access the account, and you can see we get it. And then we'll try to get the balance of that account with the following code. And then we'll write the command to send ether. So first we'll send ether, and then we'll call some ether back. So we'll these are the commands for sending. We need to specify the transactions, every value from to gas and everything, and gas price. Then we'll enter the command for send transaction. Then we'll keep you can see here send, and after that we get the balance through get balance for me, my account, and Alice's account. And then we'll call some ether back. So for that we'll copy paste this commands. As you can see here, it's not transaction, but here it's refund. And made an error, so I copied a bit different code. Copy and paste. Okay, now it's working. And then we'll define the key that of the brownie account that we created. We can get the key from the brownie information, transaction information, as I showed you before. So I already took it out, and then after that we'll wait for transaction to be received, and then we'll get the balance again. Of both my account and Alice's account. Now Alice is 0, and after that we'll for interacting with the smart contract we need to define some ABI, and for that we need to, here you can see I've already defined an ABI. I'll put this in the terminal. This is so that we can interact with the smart contract with some methods. So I've defined the methods in the ABI. Now we'll try one ABI method to see if it works or not. For that we first need to find the address, and then we can go ahead and run the ABI method. You can see it successfully runs. So this is all about the Web3, and next I will discuss this. For Slither, I have used a dataset that I've already mentioned in a research paper, and I've downloaded the Slither analyzer and all its dependencies such as the SOLC select beforehand, and because of the less time, and now I run analyze the buggy underscore for the Solidity file with the Slither, and it takes some time, as you can see, and it doesn't take really much time, and it gives me everything, every error, and about every line of code in a text file in the terminal, as you can see here. It says reentrancy vulnerability here, then dangerous calls, and everything about the call, and then everything about the functions. Also, where reentrancy is present in the functions, it gives everything, and then what functions are there, and if it's vulnerable or not, and finally it shows how many results are found. For methanalyze, we'll use for material 2 we'll use methanalyze on the 3.solidity file, and it takes very much time, much more than Slither, so I'll pause the video and resume it when it does the analysis because of the. Now the analysis is done, and as you can see here, it checks, does analysis of every code of line thoroughly, and it even detects each vulnerability, including the reentrancy. You can see here in every line of code. And so this completes my research project in which I verified two tools, and I have tried to understand smart contracts with interaction of smart contracts with Brownie and Web3. And this is my research project with some debugging and modification, of course. Thank you.